today's video, we're going to talk about mechanical schedules. So first is, what are mechanical schedules and where to find the data to modify and complete the schedules. Then we'll discuss modifying a few schedules, and they will include the condensing unit schedule, the air handling unit schedule, which are the indoor units, the fan schedule, which will include toilet exhaust and kitchen exhaust, electric heater schedule, and the diffuser and grill schedule. Then we'll also be discussing how to estimate the heating needed when selecting the electric heaters that we will be completing the schedule for. So for creating the mechanical schedule, we already have a list of templates that you could choose from. So we're first going to search this template list to see if there is a schedule specific for the equipment that we are trying to create a schedule for. So these are all the templates in the mechanical CAD. We have templates for details, schedules, risers, but for now we will focus on the schedules. So on the left side, these are the cooling, heating equipment. So we're going to start off with creating a schedule for the condensing units. So for our example, the system will be for an air-cooled split VRF system. A VRF system stands for variable refrigerant flow, and these systems are also considered heat pumps. So it does heating and cooling. This will be for a 3-family building, each with its own condensing unit. So there's going to be 3 condensing units. So going here, we're going to pick the schedule that is for this type of system, or something very similar to it that we can just take and modify. So let's go through this list. Air handling unit schedule. This is more for the indoor unit, so we'll skip this one. Here it says air-cooled condensing unit. So this is a water-cooled condensing unit, which is not the case. So far, this is the closest one. And all these other ones are for packaged water source heat pumps. And in our case, we have a split system, which is not a package system. So this is not the template we'll be using. Also, it is not a water source heat pump. It's an air-cooled heat pump. Here we have a packaged air-cooled. So again, this is not the split system schedule we need. And all these other ones are not relevant to what we need. See, these are for boilers, these are for kick space heaters, which are a type of electric heater. You also have hot water baseboard heaters. Baseboard meaning it's the heaters that you typically see along the exterior wall, interior to the building. So in this case, the most closest one to what we need is this air-cooled condensing unit schedule. So I'm just going to copy this and move it into here. And this box was created from the paper space tab right here. So this is the area we have in the title block where we can show our work. So what I did was I used the scaling that we typically pick, which is a 1/4 inch scale, and I created a box in this viewport. And that box is this white line here, which is in depth points, so it means that it will not print once we make a PDF or we print hard copies of this drawing. So this window was drawn to show us what will fit in this title page. So as long as we put everything within this box, it'll fit in that title page. So from here, we need to put it right to this corner, leaving some space, and then we're going to go one by one and put in the data for each condensing unit. So this is the roof plan here, and these are 3 condensing units. This one is the MXZ model number, and these 2 are the same PUZ model numbers here. We have to now label it with the conventional labeling standard, which is what it is, followed by a dash, then the floor that it's on, followed by the number on that floor. So in this case, it'll be ACCU, standing for air-cooled condensing unit, dash where it's located. So if it was on the first floor, it would be 1. In this case, it's the roof, so it's going to be R, and the number on that floor, so it's the first one. So this one will now be the second one, ACCU-R-2, and this will be ACCU-R-3. And I'm always going to try to avoid any type of overlap, so I'm going to move this here. So basically the idea is for leaders to be as close as possible to the thing it is pointing to, and also to avoid any type of overlap. So I'm going to move it all generally in this location here. I'll just move this way. And just to be consistent, I'll put it on this side. And I'll just point it right to the line. Okay. And I try to have some sort of consistency in the labeling. So what I'll do is I'm going to delete these so that everything looks very close to this one. So I'm just going to delete this, copy this right at this corner, and I'm just going to paste this here, and I'll move this slightly down so that the top aligns with all the other ones very closely. Then I'll just modify the text like this. So these will be the labels that we'll be using. So let's start with this first one, the R-1, which was the MXZ model number. So we'll start with this one, the ACCU-R-1. So going here, we're going to change this to be ACCU-R-1. So now I pulled up the model number specification, the MXZ model from Mitsubishi Electric. This is the manufacturer of this model. And it comes with some data here, as well as on all the other pages as well. So we're going to go through the schedule and try to find the data from the spec sheet to put into the schedule. So starting from here, we'll just fill in the data. So quantity is 1, location will be the roof. Manufacturer Mitsubishi, model number, we have to change this to this model number up here. So it's MXZ-8C48 NAHZ. Now the compressor data is right here. Also, you can also do a Control F to quickly find it. And again, it shows this location here. Now the compressor data, we need to find the kilowatts for that. So looking down here, the kilowatts. Okay, here I don't actually see the kilowatt data for the compressor. I just see what type of compressor it is. These electrical requirements are for the entire unit, so it could be for the compressor plus the fans and any other item that is using electricity in this condensing unit. So it's not specific to the compressor, this electrical information. So I can't seem to find the specific kilowatt data just for the compressor in this spec sheet. So in that case, we put a dash. Okay, here we need to see what the quantity of compressors are. Here I can't seem to find the amount of compressors indicated on this spec sheet. So I am going to just put another dash here. Nominal capacity is the capacity given according to standard conditions, and those standard conditions are listed here. If you look down here, it's when the cooling of the indoor is 80 degrees at this dry bulb temperature and 67 degrees Fahrenheit at the wet bulb temperature, when the outdoor is 95 degrees with these dry bulb and wet bulb conditions. And the nominal capacity for heating is based on these conditions here, where the indoor is at 70 degrees at this wet bulb temperature, and the outdoor is at this condition here, 47 degrees dry bulb and 43 degrees wet bulb. For this one, there's also a heating standard at 70 degrees Fahrenheit and indoor at 70 degrees. And here, these are the nominal conditions at 47 degrees and 17 degrees outdoor conditions. So down here, you see the star, the asterisk here. This is the asterisk condition. Heating at 47 and indoor at 70. Okay, it's given here. So you see that the outdoor temperature is 47 and indoor condition is 70. And you also have conditions where the it's based on 70 degrees Fahrenheit outdoor condition and 70 degree indoor condition. So they have it at both these two ratings. Basically, the interior is the same temperature and the outdoor temperature is different. From one is at 47, one is at 17. So if you look at the capacity for heating, the rated capacity at 47 is higher than at 17 because you have less heat you could take out of cooler air than at 47 degree air. So that's the reason for that drop in heating capacity based on that lower outdoor air temperature. So let's use that nominal capacity. So this nominal capacity is for the cooling side, and this is the heating side. So for cooling, this nominal capacity will be 48,000 BTUs per hour. Since it's in MBH here, we're going to divide that by 1,000. So in this case, it'll be 48 MBH, which is what we had. The sensible, it is actually not listed here. Typically, it will be listed in this section, the cooling section, where it'll give you the total and the sensible, but here I don't see that sensible rating, so I'm just going to put a dash there. So for the heating, let's use the lowest heating value just to have a conservative estimate, and we're going to use the 17 degree Fahrenheit, which is 40, and there's also a 43. So I'm going to use the lowest one, which is the 40 BTUs per hour, and we're just going to state that as 40 MBH. So here we'll just change that to 40. Corrective capacity basically means what is the rating based on our design conditions, which may be different from the nominal conditions that were listed here. And in our case, we designed the indoor cooling at 72 degrees Fahrenheit and not 80. So the conditions that we need at 72 will be different from the nominal capacity, which is at 80. So to get the corrected capacities, you could reach out to the manufacturer's rep and they can run their software to get the corrected capacities based on the indoor and outdoor conditions that you give them. So in this example, this is a typical report that the manufacturer rep would give you. And if you look here, for our case, they have the MXZ shown here in this one-line diagram. And for our example, we have 2 indoor units connected to it, which is also shown here. This looks like a future cap, so if they wanted to add additional units, they can. And also they give this blue number and this red number, which is represented as the cooling total sensible capacity, represented by the blue number, and the heating total represented by the red number. And these are the values based on the corrected capacities. So if you look at the other tab, which is right here for outdoor units, you could see here the MXZ model, and you can see the nominal capacities are listed here. which were also listed in the spec sheet here, right? The nominal cooling of 48, and heating, they used this nominal value of 54, which is here. Also, there's some other information here, such as the SEER rating, which is an energy efficiency rating, as well as the COP, which is a heating efficiency rating. And these are the conditions where the corrected capacities were generated from. So it's generated from this cooling outdoor temperature of 85 degrees and a design heating outdoor temperature of 10.8 degrees. So these are different from the nominal capacity for cooling, which was 95, and for heating, which was in the value they used at 47. So you could see the values would change based on these changes in the outdoor air condition. Now the corrected capacity is right here for cooling and for heating. So we're going to use these values into the schedule. So if you go back to the schedule, correct capacity is going to be 37.32 rounded off. 37.32. And that'll be the total. Now the corrected heating capacity is 50.52. So I'm going to change this here. So now we have to fill in this section here, entering air temperature. This appears to be for the condensing unit. So I'm going to revise this to be more clear, to state entering air temperature, outdoor unit. And I'll also state at design conditions, meaning that these were the values used to obtain the corrected capacities. So in this case, the cooling dry bulb temperature for the corrected capacity was at here, design cooling outdoor temperature, which is 85. So I'm going to change this to 85. The wet bulb temperature is not given, so I'm going to leave this as dash. And the heating dry bulb design condition is right here as 10.8. And the refrigerant, we're going to find that information out here. So, and for the refrigerant, I'm just going to search the spec sheet. And you can see here the refrigerants are R410A. Okay, so this is correct. And the pipe connections, it's all listed here. Refrigerant pipe size, liquid and gas. So the liquid in inches is this number here, 3/8, which is correct. And the gas is 5/8, which is also correct here. The electrical is also listed here in this section. So this is 208 volts, single phase, 60 hertz. Sometimes you'll see the voltage written out this way as 208/230 volt. This just means that it's rated at both these voltages. So if you're given these two voltages, use the 208 volt, which is the more standard voltage that is used. The MCA value stands for minimum circuit amps, and that is listed right here. So you can take that out, 42, and we'll change that to 42. MOCP represent maximum overcurrent protection, and that is also the same thing as recommended fuse or breaker size. They all mean the same thing. So in that case, it's 50. SEER value, we actually saw that in this spec sheet here. The SEER value is the value in red, so it's going to be 16.8. The HSPF value, which is right here, is the efficiency rating for heating, and that is 10.5. And then the dimensions, we can get that information from the spec sheet, and the dimensions are listed here. So it's in the order of H, height, W, width, and D, depth. So we're going to follow that same order. So 52, and I'll just round it up to the higher inch just to make it simpler. So this, I'll just round this up to 53, which is this. The width, I'll round this up to 42, and this to 14. So 42 and 14. And I stated 14 here because here it says 13 plus 1. So I'm thinking that it's 13 inches and it's possible it could increase to another 1 inch. So I'm just going to use 14. And the weight, I can just search for that by typing in weight. And here I'm going to use pounds, 276 pounds. Sound level, let's look for that. So we'll just Control F, sound. And it's given here. So it's 51 and 54. And 51 cooling, 54 for heating. So that's correct. And the remarks, we can add a couple of extra notes to these schedules. And typically we do have some general notes that we add. And those notes can be found in the template that we copied it from, which is the air-cooled condensing unit schedule. I'll just copy these notes. So I'll place those notes here. So now we need to add the next condensing unit. So to do that, you click this schedule, and it's actually a table. So what we can do now is click this row, right click it, and click insert row below. And what we can do here is you can just copy this entire row by clicking it, clicking this 4, right, which will highlight that row. Control C, and then you can go here and Control V, and it'll just copy everything down. And now we can modify this. So we'll call this 2. Before we go through this second condensing unit, I wanted to go back and change this because for the design condition, we also have an indoor design condition and not only this outdoor design condition. So I'm going to click this. I'm going to make a window highlighting these 3 columns here. Right click here, insert column to the left. And I'm going to make a window, highlight all this, Control C to copy it, and go here and Control V to paste it. And I'm going to name this a little differently. I'm going to call this Entering Design Indoor Air Temperature. Call that this, and this one I'm going to copy this, paste it here, and call this Entering Design Outdoor Air Temperature. And I'm going to have to fill this in for the cooling and the heating. So the design condition, so design indoor condition is right here in this tab, indoor. And you can see here that the cooling design entering temperature is listed right here, 72 and 60 for basically everything, for all the indoor units. So it's going to be 72 dry bulb and 60 wet bulb. 72 and 60 For the heating, it's going to be this column here. So the heating design entering temperature is listed here, and only the dry bulb was given. So we're just going to put 70, and it's 70 for all. So 70 here. Now we're going to start inputting data for ACCU-R-2. So quantity again is 1. Roof Mitsubishi is the same thing. The model number in this case is going to be listed here. It's going to be the PUZ-HA30. So the outdoor unit is going to be this one here. It's going to be the PUZ-HA30. So I'm going to go back here and type this in, PUZ-HA30 NHA5. So this is the submittal from the manufacturer for the PUZ-HA30. And this spec sheet also gives the indoor unit along with this condensing unit. So we need to start filling out the data, right? So compressor data, I'm going to look through this. And we see here the information on all the compressor. And if you look here, they don't give you the actual kilowatt rating, but they do give you a rated load amp rating. And with the amp, you can actually solve for the watts. Okay, so it's the formula is VI is equal to watts, or the power. V in this case is 208 volts, and you can get that by going up here, and you can see the voltage in phase. It's 208 volts, single phase. It's 208 times the current, which in this case is going to be the 18, and that's going to give you watts. So this is going to equal to 3744 watts. And to convert watts to kilowatts, you divide it by 1,000. So if you divide this by 1,000, we're going to get 3.7 kilowatts. And I just rounded this number off. So 3.7 kilowatts. Okay, now we need to find out the quantity of the compressors. And if I look here, I don't see the quantity listed here. So I'm going to leave that blank as well. I'm just going to put a dash there. And now we need to get the nominal capacity of the condensing unit. So if you look here, we can get the nominal capacity right here. So the nominal capacity, will use this value here for maximum capacity, of, which is right here, 30,000 BTUs per hour, or 30 MBH. So I'll put the 30 here. And you can also see that that rating is listed in the model number, which is very standard for model numbers for condensing units. The sensible, again, is not listed here. And the heating value is listed right here. So let's use the maximum heating value of 34. And also I'm going to change this to be the maximum as well. And going back to the MXZ model number, I'm going to use the maximum heating value here. So instead of the 40, I'm going to use the maximum of 54. So I know before I mentioned use the lower value for the heating, but I think it's better to use the higher value for heating for the nominal capacity values, because the corrected capacity will have the adjusted value. Alright, now going back to ACCU-R-2, I happen to notice this row here. It's a sensible heat factor, and you can actually calculate the sensible heat from this factor, because this factor represents the sensible over the total. So since we know that it's 0.67, we can multiply that by the total, which is the 30, and we can get the sensible in that way. So if you just multiply, so that will come out to be 20.1 MBH. So I'll put that here. Now the design condition is 85 for the outdoor for cooling and 10.8 for heating, which is the same as the one above. So this is correct. The entering design indoor temperature is going to be the same. We are right now on system 2, right here, PUZ, HA30. So if you look at the indoor unit, the system 2 would be this one, and the indoor design condition is 7260 and 70 for heating. So it's going to be the same as this one here. So I'm just going to copy this and paste it down here. And the corrected capacity is right here. So I'll put in 27.66 MBH for cooling, and for heating it's going to be 31.67, which is right here, 31.67. The refrigerant, you could go back to the spec sheet and type in refrigerant, and you'll see the type is 410A for the PUZ, so it's the same as the previous condensing unit. The liquid and gas line is right here. So the gas is 5/8 and the liquid is 3/8. So it's the same as here. The electrical is listed right here. So it's going to be 208 single phase. So this is correct. The MCA value is listed right here, but this is for the indoor unit, so this is not the correct one we need. We need to find the electrical for the outdoor unit. So we need to look at the outdoor unit section here, and we see that the MCA value is 28. The MOCP value is 40. The SEER value, we could just do a search, and we could see it's 16.5. And the HSPF value is right here at 9.5. Also, if you go here, those values are listed as well. So it's 208 single phase, which we have. The MCA is 28, the MOCP is 40, so these values are consistent. I also want to check the energy values. So SEER is 16.5, that's what we got from the manufacturer specifications, and the HSPF is 9.5, and that is the same as what we have. Now we need to fill out the weight. And to do that, we just go back to the spec sheet and we can just type in weight, and the unit weight is listed right here at 69 pounds. So we'll change that to 69. Sound level, we could do a Control F as well, so sound. Pressure level for cooling and heating is listed here, 52 and 53. 52 and 53. And remarks, we could leave it at C notes because they seem to be relevant to all condensing units. Refrigerant piping shall be installed per manufacturer's recommendations and provide service clearances as per manufacturer's recommendations. So these apply to all condensing units.